Let's look at the first smart home application in more detail, the cordless IP camera. On the left, there is a system diagram. There's two sources of power input sources that you can work with, an adapter or a solar panel. One of them is going to be connected to the USB port and provide power. Then through the battery charger, there's the battery pack, can be single cell or two cell with a gauge inside of it. Some design considerations. You want your IP camera to work in both cold and hot temperature. At hot temperature, you want to protect your cell being damaged by charging it less full, because the lower the battery voltage you charge it, the less likely it's going to bulge. To get more energy out in cold weather, however, you want to stack up two cells in series, because by doing that, you have higher voltage to work with an increased internal impedance. You need long battery runtime, so you use low IQ devices. Then the power source flexibility, you want to use the solar panel to extend the runtime. Recent years, the USB Type-C and USB PD charging is becoming more and more popular, so you may consider that. Some popular charges, the BQ25882 is a boost charger, so if you have a 5-volt USB input, it can readily charge 2S battery. If you have a single cell battery, the BQ25606 might be a good option. It's a standalone charger. Some popular gauges for IP camera, the BQ28Z610 is a single cell to two cell impedance tracking gauge. The BQ27220 is a single cell pack or system side CEDV gauge. In this slide and the next one, we'll focus on solar charging. A typical solar charging system can be found in the picture on the left. There is a solar panel, a charger, a battery, and the system, which is the DC loads there. Some design considerations. First, the solar panels are usually high impedance power sources. That means usually the power provided by it is limited with varying lighting conditions. This is why extracting MPPT is important. The VIN-DPM feature is going to be helpful to extract MPPT. With VIN-DPM, you set up an input voltage threshold. And then as you drag more and more current from the solar panel's voltage drops. And once it hits the VIN-DPM voltage threshold, it's going to limit the input current. This way, it keeps the voltage from the solar panel from dropping further. In a series of the curves on the top graph, the brightest sunlight condition is the golden curve. The open circuit voltage is around 5.5 volt. That's when you have zero current out of the panel. And as you drag more and more current, the voltage drops. The MPPT point is the red dot there. The curve on the bottom also conveys the same idea. The red curve is the power curve. So the MPPT is at the peak power. Several popular devices for solar. The BQ25895 is a single cell buck charger. It has the VIN-DPM function. BQ25703A is a buck boost charger for multi-cell. It also has the VIN-DPM feature. With a buck boost charger, it's going to make sure that you also harvest energy from the low light condition with the boost mode. The reference design TIDA01556 is specifically made for solar charging. In the system, there is a solar panel that ranges from 4.5 volt up to 14 volt. This wide input voltage range implies different lighting conditions. There is a single cell switch mode charger, the BQ25895, that has the VIN-DPM function, so it's important to extract the MPPT point. There is also a microcontroller, the MSP430, that talks to the charger through I2C. It also has the MPPT algorithm built in. The charging system will cut off input current every now and then to measure the open circuit voltage of the solar panel. Then the microcontroller will calculate the MPPT voltage as 75 to 80% of the open circuit voltage, then assign it as the V in dpm threshold of the charger. Then when the circuit closes, the charging system will extract maximum power from the solar panel. Several features of the charger specifically fit this design. The BQ25895 integrates an ADC and can monitor parameters including the input voltage, and can send this information to the microcontroller to calculate the MPPT point. The wide input range is useful to work with solar panel under various lighting conditions. It also has good power efficiency. The typical applications for this solar reference design are the IP cameras and the smart lock for shared bikes.